welcome to the special edition of In the Labs with me, Becky. Now, a few Christmases ago, I created a Nordic Santa and a two-sided snowman. Now, in this video, I'm going to add in a new character to that Christmas family set, and I'm going to show you how to create this two-sided Rudi. So we'll jump into the software and we'll take a look at the file. Okay, so in Aspire, I'm going to open the Rudi.crv 3D file that comes with the project folder. And in here, we're going to take a look at how I created the actual Rudi character. Okay, so you can see we've got lots of vectors going on here, and you can see we also have various grayscales. So we're not going to show you how to model everything in this session, but we're going to kind of go over some of the key steps, some of the key considerations to think about, and some techniques that we could potentially use that you could take on board with other projects. So we're just going to use this option here to tile our views. So we've got the 2D view on the left and the 3D view on the right hand side. So first things first, let's just go over into our material setup over here, just to talk about some of the considerations when we are working with a two-sided project. Okay, so in your job setup form, so looking at this file, or if you are looking to create your own two-sided project, you're going to need to set up your job type to be a double-sided job. Specify your job size, so width, height and thickness, in this case 7 by 9, and our material thickness is quite chunky, just shy of 1.5 inches thick. Then you set your Z0 position. In my case, I want to zero off the same side, whereby the top side I'm zeroing that off the material surface, and then for the bottom side I'm zeroing that off the machine bed, and that's you can see that's indicated using these red dots here. The reason why I like to do it off the same side is so that I'm always referencing from the same face. So this helps if there's any kind of inconsistencies with your material thickness, for example. XY date and position in the lower left, and I'm flipping this from left to right. Okay, so it's important to make a note of how you're going to flip this. I'm doing this left to right purely because I'm going to lay my material. It's quite long and thin. It's easy for me to flip that over in this direction as opposed to flipping that about the center going upwards. And because I have already modelled all of the components for Rudi, I chose a very high modelling resolution so that I'm maximising the amount of pixels that I've got my job. Okay, so we're just going to come out of that form there. We're going to go into the modelling tab. Okay, so it looks like we have quite a lot of components and it can look quite complicated, but really it was quite simple really. We've just got a series of vectors, and I predominantly use the create shape tool, which enables us to use a closed vector where we select a profile to assign to those closed vectors, and I pretty much just use the round profile for pretty much everything here, apart from the mouth, where I just use the extrude and weave tool. I've got a single line vector here. I've got a subtracted profile, and that just creates a nice kind of cut there. Okay, so what I want to do is I just want to kind of talk through some of the shapes here. Now, when I create models, I like to have access to all of the building blocks for the actual model itself, so that I can, and you can see how the model came to be. So if we just undraw these levels, and we'll just kind of work our way up from the base and talk about each of the parts here. So starting at the bottom, I created the actual body shape. So I was using this vector that we've got here. Okay, so I'm just going to undraw the guide there. I don't need that shown here. Okay, so we've got this vector here, and I just use the create shape tool with a rounded profile to create an egg style shape. in which I then chopped that egg and split it into using this vector and the original component with the split component tool. Why did I do that? Because I wanted a flat bottom, so you can see a nice flat bottom there, and that just ensures that Rudi can hold himself up and as a standalone part or a standalone decoration. Okay, so that's pretty much that. Next, we've got the fur that sits on top of the body. Okay, so this is an interesting one. We'll talk a little bit more about this. So just use this vector that we've got here, and again use the create shape tool, just a raised shape. And then what I've done is I've gone in with more detail just to kind of sculpt in the actual fur details, and I'll show you how we can do that. So I'm going to take that component, so that's selected. We're going to go into the sculpting tools, and this is quite a nice technique if you're wanting to learn how to do a fur effect. Okay, so I'm just going to use the deposit tool, so that's going to enable us to add material. Using the scroller, I'm just going to reduce the brush diameter. Now you'll notice over in the 3D view we can see the fur is a kind of glowing yellow. Okay, so that just means that that is the component we are sculpting, yet we're still able to see the full model, and that's because we've got show full model switched on. If you didn't want that on, you can just have the component visible in the 3D view. However, since our enhancements in version 11.5, I feel like this is a beneficial option to have on, because you can make your enhancements and adjustments to your component all while still being able to see the full model without actually making changes to any of the other components that are visible here, which is perfect. So we can go in and create these effects. So all I'm doing is I'm just drawing in a series of lines, and you can see I'm only, even when I come out, it's not doing anything because we're only sculpting the actual fur part. Okay, now if I go into the smudge tool, if we just increase that diameter, maybe just a little bit, and then using the left arrow key, the down arrow key, I'm just going to decrease the strength. And then I'm just going to go back and forth, okay? And you can see I'm going right over that, and I'm making all of these changes just to this component whilst seeing how it looks on top of the full model, which is perfect. And you can see we're really quickly here creating a nice fur effect, and this is how I create fur. I think it's a really nice technique, and that's pretty much how I did that. And obviously the added bonus, being able to see what that looks like on top of my model, really is a nice way of working. Okay, so I'm actually going to discard this. I don't want to make those changes, kind of like the subtlety that I had to the original fur component there. Okay, so next up we've got the head. Okay, just a simple circle. Also, it's worth pointing out actually that where I've created these vectors from, I haven't just kind of drawn them out of my head. If we just go into our layers tab here, you'll see I actually drew a sketch of a reindeer, kind of, it's very stylized obviously, drew that in, took a photo of it on my phone, and then imported it into the software, and then that's where I've drew up my vectors based on the original image that I created. Okay, so then we've got the head shape, so simple circle, used a create shape tool again, just a simple rounded shape. We've got some gloves in here, like so. We've got hooves for the bottom, again they were split as well to ensure we've got a flat bottom. Okay, so that's pretty much the base shapes. Then we've got level, so it's some of the extras to the head, so the ears, the antlers. We've got outer ears here, which I just did one, copied it over. We've got the inner ears. We've got antlers. Now, with the antlers, I originally just created this vector here and this component. Then I kind of got the heebie-jeebies and thought this might be too thin. The machining might not hold when it's actually cutting that out, especially when it gets to the other side where it has nothing to hold on to. So I kind of thought, do you know what, just for safety, let's just thicken that up a little bit. So I offset that vector outwards and created another component. And then ultimately what I've done is I've joined the two components together, which gives us a nice effect in terms of the texture for the actual antlers as well. Okay, so let's just minimize that. Then with details, so here I've got this shape which creates a real nice negative shape which kind of forms the bridge for the actual nose here. Got eyes and nose. The mouth was the only exception here where we didn't use the create shape tool. We actually used the extrude tool. So I used this rail with these two cross sections. So started off with a flat shape, so it's coming at 0 and it blends into this subtracted shape to get that recess, and then it blends back into a negative shape as you can see over there. Okay, so with all of that, what I did was I used my favourite tool in the modelling toolbox, which is create a component from a visible model. What that does is it basically takes a photograph of our composite model and it creates a composite model based on our composite model. Okay, so it takes a single model based on everything that it can see in our composite model. So when we switch all those levels off, you can see we just have one single model that is a combination of all of those things that I just shown you. And that way we have access to all of the original building blocks like I said earlier on. Okay, so that's pretty much that there. Okay, so that's pretty much the top side. So to model the bottom side, I pretty much took most of the elements or the vectors from the top side and copied them over to the bottom side by simply using the option copy to other side. And if we use this option here, that's going to toggle to the bottom side like so. Just undraw these levels just so we can take a look at that. So I'm not going to go through all of these, it's pretty much exactly the same as the top side, but you can see we've got our single component that represents the full composite model of the bottom side, and then when we go ahead and put that in a two-sided view, we can see how that looks. Okay, so that's pretty much how that works there. Okay, now if you've not done a two-sided project before, then I highly recommend that you take a look at our two-sided project tutorials. We've got quite a few videos that go through the process from start to finish on how to create a two-sided project. In this video, I'm just kind of highlighting some of the key things for us to think about, but please go and take a look at those to get to get you up and running with a two-sided project from start to finish. Okay then, so that's pretty much the modelling side of things. So now we need to think about how we machine this, how do we keep everything aligned when we come to flip our material over, and also how do we hold our model to our material block when ultimately we're actually going to be cutting out everything on the outside. Okay, so first thing we'll talk about is how we're going to align the top side when we machine that to the bottom side. So we're going to use dowels. Okay, so I've got some dowels in the labs. I've measured the diameter. They measure up at 0.41 of an inch. Okay, so I've drew a circle using the draw circle tool, and I've basically drew that out to the same diameter as my dowel. And then I've copied that and then I've just randomly positioned them in an asymmetric fashion. Okay, the reason I've done that is so that when I come to flip my material over, there's only one possible way that we can locate the top side to the bottom side, whereby the top side we will be machining away, we'll be pocketing in these vectors, and then we'll put our dowels into the holes of the top side. And then on the bottom side, where we've copied those vectors over, we're going to be machining the dowels for the bottom side directly into our spoil board so that the two align perfectly. And by doing this in an asymmetrical fashion, it also ensures that there's only one possible way for us to actually flip our material over, so we don't have the confusion or the mistake of flipping it in the wrong direction. If we had our dowels set up in a symmetrical fashion, for example, if you just had two that was opposite each other, you can run into the case of flipping that the wrong direction and then you end up cutting it the wrong way round. So this just ensures that you're never going to flip your part in the wrong direction, because there's only ever one possible way that you could possibly locate the top side to the bottom side. Okay, so going back to the top side here, and if we go into the modelling tab, you see I've got two levels here. We've got a limit plane and 3D tabs. So let's just go into the 3D tabs to begin with. Okay, so 3D tabs, we need something to hold our Rudi in place to our material block, otherwise it's just going to fall out and it's going to get very messy. So where did I get these tabs from? Well, in your clip art tab you have access to 3D tabs. It's got various different shapes and sizes to choose from, so I just used the circular 0.5 option. Just drag that in and then just position them around my part, size them, and kind of took a look in the 3D view at how they're interacting with Rudi. So they're not too intrusive on the main body. However, for the antlers, you can see that we're going to need to do some manual sanding here. And the reason why I wanted some tabs in here is just because I wasn't sure if the antlers would be too delicate when cutting if it has nothing to hold onto when we come to cut the bottom side. And so just for extra measure, I just wanted to add those tabs in. But obviously you're going to need to remember that we're going to need to do some sanding just to remove this area of the actual tab itself and try and blend that in with the antler. Unless you're brave enough to do it without the tabs, but I recommend you have those tabs in place so that you don't end up having any breakages. Okay, so that's pretty much the tabs, and what I did was I just simply again selected all of those tabs and then used the option to copy to the other side, so we have those tabs visible on the bottom side as well, which we'll come and talk. Let's just have a look at that now. So in the modelling tab, switch on those tabs and you can see them there, and again I would have adjusted the heights according to how it's interacting with the overall composite model. Okay, so let's just switch back over to the top side. Okay, so we spoke about the 3D tabs and the dowel positions, how we keep everything aligned. Now, when we're machining our top side and our bottom side, wherever we position our model within our material block, whatever that centre is, that's where the centre of the tool is going to go when we cut both sides, okay? And that could present us with the cusping effect because of the fact that we're using a rounded tool in our finish pass. When it gets to that centre, we could be presented with a seam. So what we want to do is we want to tell the tool just to cut a little bit past 0, and the only way for us to do that is by implementing a 0 plane, or in this case I call it a limit plane. I call it a limit plane because I'm basically naming it that as a limit for where the tool is going to go. Okay, and so it's essentially just a 0 plane, so using that on here. Okay, I've actually created another one. I didn't want to do that, so let's delete that. And then in the 0 plane component that we already had in place, if we just go to the properties there, you'll see we've got a base height of negative 0.1. So basically what we're doing is we are telling the software we want the tool to drop down past, so you can see this line. If we look at that, the y-axis, okay, so if we just move that over like so, okay, so this plane that you can see here is essentially our modelling plane. That's the centre of our full model, but this red plane here is our limit plane, or our 0 plane, where it's got a negative height, so we're dropping it down so it's negative by 0.1. And what that will help us do, will help us drop that tool down past the centre line to ensure that we don't have that cusping effect. So that's a good technique to include in your two-sided 3D projects. Okay, and we've also applied that to the bottom bar just for extra measure. Okay then, so that's pretty much the modelling setup. So now we can quickly go over the toolpaths. Okay, so we'll just switch over to the toolpaths tab. Okay, so let's go over our material setup. So for the top side, we're setting our Z0 on the top surface of our material. Model position in the material, I've put that bang on in the centre of our material to ensure that we have a gap above and below that's matching each other. And this just ensures for any discrepancies in the material thickness itself. Okay, and then we'll just go ahead and you can just OK that. Right, and so the first toolpath we're going to create is a pocket toolpath. So in there, I've already created these toolpaths. I'm just going to go into the forms and we'll just quickly go over what's in there. Okay, so we're going to use those dowel hole vectors. We're going to cut down 0.4 of an inch using a 1/4 inch end mill, using an offset strategy. And then we should have something that looks like that. At this stage, what I'd do is I'd take my dowels and I'd check that those dowels fit in those holes. If they didn't, I'd make them bigger, and so on. Okay, so we're just doing that. You just want to make sure that those actually fit before you go any further. So we'll just close out here. Okay, so next up we've got a 3D roughen toolpath. So we're just going to double click on that. Okay, so we're going to use a 1/4 inch end mill to do our roughen pass. Our machine and limit boundary, we're actually making use of the level this time. And the reason for that is because I want to tell the software, I want you to choose my machine and limit boundary to be the result of whatever is in this particular level, which is the actual composite model minus those tabs. Okay, so it's just the sculpted version of Rudi. And what that will do is it's just going to take that outline like so, and we're going to machine around it, but it's also going to factor in the actual 3D tabs, so it machines those tabs in place, so it holds Rudi all together. Okay, we're going to put in an offset of 1/4 of an inch, so the same as the same diameter of the actual tool itself, and that's just to ensure we're creating a nice big gap around the outside. And then we're just going to go in with a machining allowance of 0.04. It's like a skin of material ready for our finish pass, and then we'll go ahead and see what that looks like. So we'll preview that one. Okay, so that's what that looks like. So you can see all of the different steps in there, and you can see how that looks. Got a nice gap around the outside as well, so we're ensuring that our tools can fit in at the edge of our part. Okay, and then we can close out into the finished toolpath using an 1/8 inch ball nose. Again, same level, offset matching the diameter of the actual tool. Then we'll go ahead and preview that, and we'll see what that looks like. Okay, so we can see those tabs in there like so. Okay, so you can see they're being part of the actual cutout because it's taken the composite model. However, the actual boundary is we're actually using the component of the sculpted Rudi component as the actual boundary, but it's taken the composite model into effect. That's why it's including those tabs in there. And here, if you take a look at the preview, you can see again, this is where we'll need to pay attention in our finishing when we come to actually take everything off the machine and ensure that we create a nice antler just by doing a little bit of hand sand in there. Okay, so we'll close out here. So that's pretty much the top side. So at this stage, what we'd do is we'd take this board, okay, so that's our part that we're cutting into, and we're going to take it off of our machine bed. Okay, I'm just going to put that to the side for one moment. And the first operation that we're going to do is we're going to machine the reverse dowel holes of the top side that are on the bottom side, so these ones here, into our spoil board. Now this also gives us the option to machine the bottom side in a totally separate occasion. You could do this now, you can do this tomorrow, next month, next year, whenever you want to do that, because the first thing you're going to do is you're going to rehome your CNC, set your X zeros, your Y zeros, and then your Z zeros, which in this time we're setting that from the machine bed in this instance. And the first operation is you're going to take those dowels and we're going to machine those position of those dowels into our spoil board, and then that's going to enable us to give us perfect alignment with both the top and the bottom sides, because the dowel holes is basically where everything gets aligned between the two sides. So let's go into that toolpath. Okay, so because we're setting our Z0 on the material surface, we're going to tell the software we want our start depth to be the full depth of our material thickness, and that's going to take us to the machine bed, at which then we'll then cut in 0.4. Okay, and then we're going to use the same tool, and that should do that. So let's just preview that. We'll just switch that on, so you'll see here what I mean by the start depth. Okay, so remember, we're not actually going to have our block of material on here. What we are going to do is we're going to tell the tool to drop down by the full length here, and then you start cutting here, okay, which is going to be in your machine bed. Okay, so by 0.4, and obviously you want to adjust these values according to what's safe for your particular machine. Okay, so once we've got the dowel holes in position, we can take our block of material, we've got our dowels in, and then we simply turn it over, locate it to those dowel holes, and then we'll secure that by screwing our material into the spoil board. And then we have perfect alignment, and we can now move on and think about the other toolpaths, whereby we're going to go into the 3D roughing toolpath. So the exact same settings there. And you can see when we cut that, we're actually cut through here. We can start to see what that looks like. So you can see having the tabs, I am glad that we've got tabs there, because it's part of me feels like it might not hold itself. So that's why we've got those tabs in place for those antlers. And then the finishing toolpath, we'll preview that. Again, same setup there, and that's what we've got here, and everything looks great. We've cut all the way through. That's thanks to that limit plane. We've got no kind of cusping or seam effects there, and that looks pretty good. So that's pretty much how Rudi came to be. And like I said, if you've not done two-sided machining before, then I totally recommend that you go ahead and watch our tutorials on two-sided machining. It kind of really goes into detail this whole process of how to create perfect alignment between the two sides. Right then, so let's go over to the labs and see how he turned out. So there we have it. I loved how Rudi turned out, and if you fancy having a go at creating your own two-sided Rudi, then simply head over to your V&Co account where you can download the free project files from there. And if you like this video, give us a thumbs up, and if you've not yet subscribed to our channel, then please hit that subscribe button for instant updates on the latest videos that we'll be releasing. So thank you for watching and happy making.